Hi, question number 4. Number 4a, a square coil 50 turns wire has side 15 cm, 5 cm is placed in uniform magnetic field 20 millitesla so that the field perpendicular to the plane of the coil. Calculate the average induced EMF at the time t 0.1 second. So to calculate the induced EMF is given by the equation negative n number of turns times the chain or rate change of flux, d flux or dt. Now the value of the n number of turns is equal to 50, right? And the time taken now is a 0.1 second. So what is the change of flux? So the problem here is how to calculate the chain of flux. So the chain of flux is equal to the change of flux is given to the flux final minus flux initial. So flux initial here is a, you can use the flux initial equation B A cos theta, right? So the initial B, magnetic field B here is 20. This is a milli is a time 10 power of minus 3, right? Millitesla. And the area A is a 0.05 square, 0.05 sorry, and cos theta. So what is the theta here? Because to start with the field perpendicular to the plane, meaning the theta is equal to 0, right? So this is equal to 1. And the flux finals is the same process. B is a 20 minus 3, right? But okay, because the final, if you get the equation, the flux on the final is a BA cos theta. At the final, when the coil start is pulled from the magnetic field in the time 0.1 second, meaning the theta here is a 90. So this is equal to, this is equal to 0. So the meaning the flux final is equal to 0. So now this is equal to 0, meaning you have a negative 5 exponent minus 5 Weber. So this is a delta flux. So you put the value of delta flux in the equation here. So now you have a induced EMF is equal to 2.5 exponent minus 2 volt. Number 4b, a solenoid 400 turns, length 25 cm and diameter 4 cm, and the current flow through the solenoid 6.5 amperes. So now calculate energy stored in the solenoid. To calculate the energy stored in the solenoid, you can use the equation U is equal to half L I square. This is a current. So now the current here is 6.5. So now the problem here is the L. So what is L? L is an inductance, right? So how to calculate the inductance? So the equation or formula to calculate inductance, you can use the nu naught n square area A divided by length of the solenoid. So if you refer to the questions, you can find the information is nu naught is constant. This is 4 pi exponent minus 7, and number of turn is 400, and the area of A, because this is a diameter, so you can find the area of A is 4 pi exponent minus 4. This is area A, and the length of the solenoid is 25, meaning the convert to the meter is 25 exponent minus 2. So you can find the value of L here is 1.01 exponent minus 3 Henry. Now you can use the value of the inductance here to find the value of the L. So you can use the calculator here. The energy stored in the solenoid is 2.13 exponent minus 2 joule. Right? So this is the value of the energy stored in the solenoid. So next question, number B2, a 100-turn coil is found that's coaxial around the solenoid. So now the solenoid here, you have another 100 turns coil. So calculate the induced EMF in the coil when the current decrease uniforms to 0 within 0.4 seconds. Right? Okay, so how to calculate the induced EMF? So you can refer to the equation. E induced EMF is equal to negative. This is M, it's for inductance, and this is the rate change of the current flow. Because the currents here is from 6.5 to 0, so meaning you have the change for the current is because 0 minus 6.5 means this is a minus 6.5 ampere. Alright, this is come from the current final minus current initial. Right, so you have a negative 6.5 in the time t in 0.4 second. So the problem is the M. So the M here is mutual inductance here. So you have 2 turns here, 400 turn and 401 turns. So you can find the mutual inductance M. You can use the equation nu naught N1 N2 time area of solenoid and the length of the solenoid. So the value is as well nu naught is a 4 exponent minus 7 4 pi, right? Minus 7 constant, and the number of turn at N1 is 400, and the second turn is 100, and the area A is the same value of the area A here. This is 4 pi times 10 exponent 4. This is area for area A, and the length of the solenoid is 25 minus 2 meter. So if you use the calculator here, M here is 2.53 exponent minus 4 Henry. Sorry, Henry H, right? So now you can use the value of the mutual inductance here to the equation here, so you can find the induced EMF is equal to 4.11 exponent minus 3 volt.